Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is really just spend a little more time working with some function composition and inverse stuff to make sure we're really good at that before we kind of move on to like really studying specific inverse functions, namely the root ones. But I just want to do one kind of cool problem that uses a lot of this kind of stuff. So let's just do it. So we have a function g of x here, and I say if g of x is 2 times the inverse function of f, and f of x has the structure like ax plus b, what is a plus b over 2? Okay, so it's kind of like pop in what we know so far. We know g of x is 3x plus 2, and we know that equals 2 times the inverse of f, right? And so we probably want to get the inverse of f here, right? So if you do, the inverse of f, right, you got to switch x and y. So instead of y equals ax plus b, we're going to have x equals y plus b. And then solve that thing for y. So x minus b equals ay. And then x over a minus b over a is y. So this is my inverse function of x now, right? So if we kind of go back, put that in here, right? We're going to have 3x plus 2 equals 2 times x over a minus b over a, right? And then we can also divide by 2, I guess. And so if we divide by 2, right, we'd have 3 halves x plus 1 equals x over a minus b over a. And I did it this way because now we can kind of match some stuff up. So we have this. There's only like one, x term here, one x term here. So this has to be equal to this. Likewise, this has to be equal to this, right? So if we use the orange stuff kind of first, we know 3x over 2 has to be x over a, right? And so that would mean, you could either cross multiply, or you can just, that like 3 halves, the way I just see this is 3 halves needs to equal 1 over a. So a needs to equal 2/3, right? You just need to do 1 over 2/3 to get 3 halves, right? So we got a. That's good. So this is going to be one of the things that I really need. And then for the purple stuff, we know that 1 needs to equal negative b over a. But we know a is 2/3, right? So, you could multiply by 3 halves if you want. But you can see that if you multiply by 3 halves, well, I was going to flip around the side. Let's not do that. So I'm just going to multiply by 3 halves just to make this thing, like on top and bottom, just to make it like a little nicer. So I have 1 equals minus 3b over 2, right? And then times by 2 divided by negative 3, you can see that b is negative 2 over 3, right? And so now you have a and b, and you can just go and plug them in, right? We want a plus b over 2, and a is 2/3, and b is minus 2/3, and divided by 2, it's really just 0, right? So that's just kind of a weird function notation question. A lot of the SATs, ACTs and stuff, they love these kind of questions. Just kind of making sure you know how to work with the symbolic stuff given in this question. So we're going to have like a whole nother work day related to function notation and composition and all that. But this is just kind of a weirder problem that I thought would be good, just kind of extra practice with this notation that we've been learning.